All right, we're continuing on our lesson on alliteration. Seems a little bit strange for math, but we are in the power of power property. Power of power property. Man, I can't even say it. And we are in the power of product properties. So, we've already dealt with a couple of these. There's a lot of these as we deal with these exponent rules. Okay, so I have two more rules we're adding today. This will be the guided practice off page 34. It's chapter 1, lesson 4. And what we're looking at here is you have a power, 3 squared, and it's going to the power. So I want to write one of these out so you see what you're actually dealing with. If I have 3 squared to the 5th, that means I have actually 3 squared, and how many of those do I have? I have 5 of them. 1, 2, 3, 4, 5 of them. So if we go back to the product of powers that we dealt with yesterday, man, I can't say these words, then I would say, well, they have the same base, so I could add these. 2, 4, 6, 8, 10. This would be equal to 3 to the 10th. There's a quick way with this. This is, if it's a power to a power, you simply multiply the exponent. So 3 squared to the 5th would be 3 to the 2 times 5, which is 3 to the 10th, exactly as we found. So rather than writing this one out, we'll use that property now. H to the 6th to the 4th. That means I would have 4 h to the 6's. I could add them repetitively or take the shortcut h to the 6 times 4, which is, I'll just show that this way, h to the 6 times 4, which is h to the 24th. So now we have one that is a power of a power of a power. So inside the brackets, I have another parenthesis that I would try to do first because I'm doing order of operation. Can't do anything inside there. Actually, I could if I wanted to do 2 to the 3rd, I could 8. But 2 to the 3rd squared, remember? 2 to the 3rd squared would be 2 to the 3rd times 2nd, right? So 2 to the 6th. But that thing is still to the 3rd power. So this thing is 2 to the 6th, but that whole thing is to the 3rd power. Again, I'd have it 2 to the 6th times 2 to the 6th, 2 times 2 to the 6th, or 2 to the 6 times 3, which is equal to 2 to the 18th power. And you could solve that if you want. I don't think they ask you to on this. They just ask you to write them with exponents. Okay, so the next one. We still have a power to a power, but this is also what we call the power of products, because I have 2 things multiplied, and then that whole thing is going to a power. Because remember, this 3rd power touches this parenthesis, so everything in that parenthesis is going to the 3rd power. You may not realize that the 7 has an exponent, but remember, it has an understood exponent of 1. So 7 to the 1st to the 3rd would be 7 to the 1 times 3, or 7 to the 3rd. W to the 7th, of course, would be W to the 7th to the 3rd, so it's W to the 7 times 3, or W to the 21st power. Now you could work this out and get 343 W to the 21st power, but of course we're working on power, so I would accept this 7 to the 3rd as well. Number 5. Notice I have power to powers, but I have a power of a product that has several different pieces in it. So this is a 5 to the what power? 1st power. 5 to the 1st to the 4th is 5 to the 4th. G to the 8th to the 4th. Remember what that looks like. Write one out again so you see it. That would look like G to the 8th times G to the 8th times G to the 8th times G to the 8th, because it's G to the 8th to the 4th. So if I add them all up with my property we dealt with yesterday, I could add 8 4 times, or we could do the shortcut that we learned today. 8 times 4 is 32, so I have G to the 32nd, and K to the 12th to the 4th. Once again, multiply the 12 and the 4, and you get K to the 48th power. So that'd be 5 to the 4th, G to the 32nd, K to the 48th. All right, we have another one just like that. I have a negative 6 to the 2nd power. Is that negative going to the 2nd power? Yep, it's inside the parentheses. So a negative times a negative is a positive. I have an even number. Remember how we talk about even numbers pair up and we have a positive. So negative 6 squared is the same as 6 squared, really. I'll just go ahead and work that one out. That's 36. R to the 10th. S to the 18th. 36r to the 10th, s to the 18th. Number 7. Number 7 says the floor of the commons room at King Middle School is in the shape of a square. So I'm going to draw a picture. You should always do this when you have geometry or shapes that you can't see. Things I know about a square: 4 right angles, 4 congruent sides. Okay. In the shape of a square with side lengths of x squared y cubed. X squared y cubed. All right. And then it says, new tile is going to be put on the floor of the room. Find the area of the floor. Well, if it's a square and this is x squared y cubed, then this is also x squared y cubed. And to find the area, I take length times width, or side squared in a square, right? So that means I'm basically taking x squared y to the cubed squared. So let me show you that. That would be x squared y cubed squaring it. Okay, we just practiced this, so you ready? Oops, can't see it. X to the 4th, y to the 6th. X to the 4th, y to the 6th. And that would then, of course, be feet. Not feet, but feet squared, because we're dealing with units squared. Okay?